Hey guys, welcome back. So today we're going to be looking at how to complete the square. That is, when we have a quadratic, we're going to look at how to factorize and solve it by doing this method called completing the square. And usually you'll have to do this if the normal PSF method doesn't work. And it won't work when your answer to an equation like this, and by answer to an equation I mean the values of x that are going to make this left side equal 0 so that the equation works, are going to involve some kind of square root number. They're going to be irrational. Usually when you do the PSF method and you're able to put this quadratic straight into two brackets, the solutions to that quadratic are rational numbers. They're fractions or they're whole numbers. Now we're dealing with a situation where the answers to this, right, the answers or solutions, the values of x that are going to make this left side equal 0 so the equation works, are going to be irrational. They might involve a square root sign. Okay, so how do you factorize and solve an equation by completing the square? Well, let's first look at what a perfect square is. Let's remember what that is, because when we say completing the square, we really mean completing the perfect square. We are going to create a perfect square in our quadratic, even though it isn't already there. Now, what is a perfect square? A perfect square is when we have something like x plus 3 squared. That's a perfect square because it is a bracket with two values inside and it's squared. And we know that if it's a perfect square, really that's the same as saying x plus 3 times x plus 3, because it's the same value times itself is x plus 3 times x plus 3 is x plus 3 squared. And if we did our long expansion and we times everything in these brackets by each other, you would end up getting x squared plus 3x, 3 times x, plus 3x again, plus 3 times 3, which is 9. We're going to get x squared. Add these two middle ones together. That's very important. You'll notice that because the brackets are exactly the same, these middle terms are going to be identical. You're always going to be adding them together. So there is always going to be two of them, right? So there's two of these middle terms. And how do you get this middle term? Well, really, we could have just said it's this number times this number. It's plus 3 times x, which is 3x. That gives you that. And we know that we're always going to get two of them. So you double what this term and this term are multiplied together. We know that plus 3 times x is 3x, times 2, because you will always get two of them, is plus 6x. Plus 9. Okay, great. Now what you need to notice here is that this middle term here, plus 6x, it represents double what these two terms were times together. Therefore, if you didn't get this information and you simply saw this line, and I wanted to know if this was a perfect square, the way to recognize if something is a perfect square already is to say, well, if I halve this middle term, plus, and I don't include the x, I just look at the number next to it. If I halve this number next to x, so if I divide that by 2, that equals 3. And notice that half of that number will always be the number that goes into the bracket that is a perfect square. So half of 6, if I divided 6 by 2 there, I've just done 6 over 2, it equals 3. And then if I square that, because the last term, remember, is always just going to be 3 squared, which is 9. If I square this, then I do 3 squared, which equals 9, and that's 9. So therefore, that is a perfect square. So in other words, if half of this middle term, and by the middle term, again, I'm not including the x, I just mean half of the number next to x in the middle term, if half of that squared is the last number, then you've got a perfect square. Okay, so let's go back over to this equation. We want to solve this by completing the square. And what we're going to do is we're going to say, first of all, we're going to make sure that this quadratic is set up so that all terms are on one side and it doesn't equal 0. We're also going to make sure that the number next to x squared is 1. That's very important. Completing the square won't work if the number next to x squared is not 1. So if you get a number other than 1, make sure that you factorize that number out of all the terms, okay? So that you're only left with x squared inside a bracket. That is before you start the process. Okay, so we know that number's 1, and we know that x squared is positive, make it positive, and we move it all to one side, okay? Now we go, I'm only interested in these terms for now, these two terms for now, x squared plus 4x. Forget about the plus 2 for a second. I want to know if I already have a perfect square. Well, how do I figure that out? Again, I grab this plus 4 bit, and I go, well, plus 4 halved, so plus 4 divided by 2. Again, you do include the plus when you do this. If it was negative, that would be here as well. Plus 4 divided by 2 is 2. And 2 squared, I'm getting this number here, goes down here. I'm squaring it, and it equals 4. That number is not 4. Therefore, I need to put 4 into our quadratic. Okay, so what I'm going to do is, I'm going to write x squared plus 4x plus 4, because I know that if half of that number squared is 4, if I add that in, this is a perfect square, as we saw here. Okay, so I have x squared plus 4x plus 4, but I've added in 4. I didn't have 4 originally. Therefore, I'm going to continue writing what I had before, plus 2, and the only difference is now that I have plus 4 there, which wasn't there before. So I have to minus 4 on the outside. You added 4 and you minus 4. So really, you haven't actually changed anything about the original quadratic. Okay, we've also established that x squared plus 4x plus 4 is a perfect square. And we know that half of this middle term, as I showed you before, half of that is always the number that goes into the bracket with x. So half of plus 4 is plus 2. So really, this x squared plus 4x plus 4 bit is the same as x plus 2 squared, because half of 4 was plus 2, and plus 2 pops into the bracket like that. Okay, what else did I have? I had plus 2 minus 4. So in terms of this bit, I'm going to work out what plus 2 minus 4 is, and that is minus 2, and then that whole thing is going to equal 0. Okay, so what we have here is that this line here is exactly the same as that line. I have just manipulated it to make this first bit a perfect square. So now I have a bracket. The next thing you do, and I'm going to rub this out, is we're going to realize that right now we have two terms, essentially. We have this bracket squared minus another number. That means that we can use difference of two squares. What we're going to do now is we're going to remember the formula that a squared minus b squared equals a plus b, a minus b. Therefore, if I have this number, we're going to treat the whole bracket as one number as our a. We're going to have a squared minus, and this is going to represent b squared. And obviously, the b must be the square root of 2, because the square root of 2 squared is 2. So we'll say the square root of 2 equals b, because that represents b squared. So really, if we take this line and I rewrite it up here, we're going to be left with x plus 2, because that's our a, x plus 2 is a, plus root 2, because that's our b. A equals x plus 2 because it's a squared, and root 2 squared is 2, so that's our b. And then we're going to close bracket, and then we're going to go a minus b. And remember, a is x plus 2. And we're going to go minus b, which was root 2. So the key thing is that we have done plus and minus our a and b, just as I did there, plus and minus. That's what the difference of two squares allows us to do. So we really have that bracket, and there would be equal 0 there. So this is then going to come down here, and we're going to expand these brackets inside the bigger brackets, and we're going to get x plus 2 plus root 2 bracket, x plus 2 minus root 2 equals 0. And of course, to finally solve it, we just simply make each bracket equal to 0, because if this bracket equals 0, 0 times this whole other bracket is going to equal 0, and that will solve our equation. So our first answer will be given by the value of x that makes this bracket equal 0. And we also wanted the number of x here that is going to make that whole bracket equal 0. Because again, 0 times this bracket will equal 0 no matter what was in that bracket. And if this bracket equals 0, 0 times whatever was in here is still going to equal 0. So we're going to get x plus 2 plus root 2 equals 0. And then if I move plus 2 to the other side and plus root 2 to the other side, we're going to get x equals minus 2 minus root 2. And then I'll put a separator there. If I do the same thing to the other side, I'm going to get x plus 2 minus root 2 equals 0. That's just that bracket. I want to make it equal 0. And I move these two terms to the other side. I'm going to get x equals minus 2 plus root 2. And that's how you factorize and solve by completing the square.